Hello. In this video we will talk about solving second degree equation in the complex numbers with real coefficients. Look at the definition first. The definition says if a is a real number, that means if a belongs to the set of real numbers, okay, and b is a complex number, so a is real and b is complex, then we say that b is a square root of a real number. A complex number is a square root of a real number a, if and only if b square equals a. This means if b square equals a, then we say that b is square root of a. What does that mean? B is square root of, if it is true, then we say that this is true. Okay, so this is the definition, and this is true for if and only if. Both sides are true. What does that mean? If this is true, then b is equal to square root of a is true, and similarly, if this is true, then this is true. Okay, this is what we mean in this definition, right? So this is the mathematical form of this definition. So that means, in other words, we are taking the square roots of a, where a are real numbers. Okay, so we have three different categories of real numbers. Okay, so the first case is if a is equal to 0, then if a is equal to 0, then what is square root of a? Then square root of a is also 0. Square root of a is only one value. Okay, that means square root of a is equal to 0 is only one value. So why I'm saying it's a value in C? Because square root of a is equal to b, and b belongs to C. Okay, so if I am talking about a real number a, that means I am talking about real number. If I am talking about square root of a, but square root of a is equal to b, that means I'm talking about the complex numbers. Okay, so I took real number, which is a, I land inside a complex number. Okay, similarly, I will do case 2. There are three different cases. The first case is when a is equal to 0. The second case is when a is positive. Positive means on this side, on the positive side. Here a is bigger than 0 and here a is less than 0. So we will consider all of these three cases. Since I have already considered a is equal to 0, this case is done. Now I will consider this case when a is positive. So if a is positive, the second case, then we have two. Then what is square root of a? Square root of a are the two different values. Then square root of a and negative square root of a are the two different values. Okay, they are the two different values in C. But when we are in this side of the real line, then the square root are also in the real line. So they must be in C, but in particularly we say in R. Okay, the rule is that whenever we take a square root of a real number, that must be equal to b, and b must lie in C. But in the field of complex numbers, we have this line also. Okay, That means if some number is in C, numbers in the complex numbers can be anywhere. If they are here, not in this line, that means they are not real numbers. But the numbers inside C can be on this line, on this straight line, horizontal line, and this line is inside C. Okay? So I am saying if you take square root of these numbers, I mean when a is 0 and when a is bigger than 0, if you take square root of these numbers, you will lie in real numbers. I mean your answer will lie on the real line. But if you take square root of negative numbers, then your answer will not be on this line. Then your answer will be here or up somewhere else. Make sense? So in second case, we have a is bigger than 0. So then there are two different square roots. The one is square root of a, the other one is negative square root of a, which are two different values in C, but in C we have a real line also. They must lie in R. Okay? If we talk about case 3, in case 3 we have a is less than 0. If our a is less than 0, that means if we are in this side, on this side we have again two different values. Then square root of a and minus square root of a are in C, but not in R. So these are three different cases. In the first case, when the number is 0, then its square root is in C, also in R. Also in R also, right? And similarly, if a is positive number, then square root of a and minus square root of a are two different values in C, but also in R. But if your real number is negative, then square root of a is in C, but not in R. So that means when you take the square root of negative number, then you are not landing in the real numbers. You will land somewhere else in the imaginary world. Okay? Okay, now we do different examples of square root of a real number. Suppose this is a real line. Here you have 0, here you have positive numbers, and here you have negative numbers. Suppose you have here negative 9 and here you have positive 9. I will take the square root of this and then square root of this. Okay? Since 9 belongs to R and 9 is positive, also 9 is positive. So the second case this example fall in the second case. This case says if a real number is positive, then it has two square roots and two different values in C, but also in R. Let's check. What are the square roots of 9? Then square root of 9 and minus square root of 9, you know, R. What is this value? This value is 3 and this value is minus 3. You know, they are complex numbers, but they are also real numbers. Okay? But now if I take this number, which is negative, if I go to the third case, this case, then what is the square root of negative 9? Since negative 9 belongs to R, but negative 9 is less than 0, so we will fall in the third category. In the third category, we said if we take a square root of negative number, then what will happen? Then we are not in R, we will be in C. Let's look what will happen. Then negative 9 square root and negative 9 negative square root. What's that mean? This means the square root of negative 9 is 3 iota. And okay, let's look how we can find. First of all, negative 9, we have to find this and this with negative, okay? We have to find two square roots of negative 9. The one with plus, the other one with minus, okay? Let's look how can we find. First we find plus. Plus, you can write negative 1 times 9 inside. You can write it negative 1 times 9. Okay? Since this negative 1 is iota and this is 3, that means you got 3 iota. Similarly, if I write negative of negative 9 square root, it is equal to negative of negative 1 times 3, negative of negative 1 times, okay, not 3 here, we have 9, negative, this thing is iota because square root 1 is negative 1 is iota, and this thing is 3. So that means you got negative 3 iota. So what happened? You know, when I took the square root of negative 9, I got something in iota, and iota is not a real number. Okay? So we have proved when we take positive real number and take its square root, we will land in the real number again. But if we take negative real number and take its square root, we will have two different values, but we will not lie in the real numbers. We will lie in the complex numbers, just like this and just like this. Okay, let's do another question. Okay, first look this question carefully. Find a real number. We have to find a number which is in real line whose square root is 7 iota. Here is the solution. How can we find this real number? Okay, what is our target? To find a in the real number such that the square root of the real number is 7 iota. What does that mean? Square root of a is 7 iota. We have to find a. Okay, this is given. We have to find a real number a such that if we take its square root, we get 7 iota. This is the question. Okay, if you are able to write question in mathematical form, that means you can solve the question easily. Now our aim is to find a. How can we find a from here? Because a is inside square root, but we need a without square root. How can we do that? The only way to find a from this equation is to take square on both sides, because if we take square of the square root, then the square will kill this square root and we will get our a. Okay, so we can take square both sides. We will have square of this equals square of this. Since this square will kill this square root, here we have a, and here square of 7 iota is 7 iota times 7 iota. That means 7 times 7 iota times iota. 49 iota square. Since iota square is 1, iota square is negative 1, Okay, that means this is the negative real number whose square root is 7 iota. In other words, the square of 7 iota is this real number. Okay, so we have solved this question. If I give you a question in another way, so I have given you a question. The question says, find a complex number whose square is 2. Here is the solution. So first of all, the first step is to transform our question in mathematical language. We have to find a complex number. So that means we have to find x belongs to the set of complex number. We have to find a complex number such that the square of this number is 2. Such that the square of this number is 2. Okay? Such that the square of x is 2. How can we find? Since we have x square, but we need to find the complex number x. How can we find x from this equation? If you have square and you are going to find a number without square, that means you take square root on both sides. So apply square root on both sides. We will get x square square root, and here plus minus square root 2. Okay, because whenever you take square root, you have plus minus because of these cases. If you look at the previous cases, in this case we know, because if our real number is positive, then its square root are two different values. Okay, so we are given a real number, and this real number is positive. Since it's not negative, it's positive, so its two different square roots are plus and minus. Okay, so here x is either plus square root 2 or minus square root 2. So this is the answer. Okay, so this is the basic theory which is needed to solve the quadratic equations. Now let's come to the point. So in this video, our main target was solving the quadratic equations with real coefficients. So we suppose that a second degree equation is ax square for the second degree plus bx plus constant equals 0. I mean, we need the second degree equation in R such that one term with no x, second term with x, and the third term with x square. This is called second degree. Second degree means the maximum power of x is 2. Okay, so we have a second degree. It is usually called the quadratic equation also, such that its coefficients are real, such that a, b, c, which are the coefficients, are real. They are not complex. So the beauty of this thing is that you will have an equation whose coefficients are real, but it's when you will be solving this equation, you will land in C. So its solution will not be real in some cases. They will be in the set of complex number. Okay, so we know how to solve this quadratic equation. You know, we can solve this quadratic equation using the quadratic formula. The quadratic formula says x is equal to minus b plus and minus 2 solutions of square root of b square minus 4ac over 2a. Okay, so in this formula we have square root. Since we have square root of real numbers, because a, b, and c are reals, so that's why we were talking about taking the square root of real numbers. Okay, this real number can be three kind of it has three types of real numbers. It can be 0, it can be positive, it can be negative. If it is 0, if it is positive, then there is no problem. If this real number is negative, then we will land in C, in the set of complex numbers. So we will say, if this we call this thing inside the square root discriminant, okay? Discriminant which is D, this is equal to B square minus 4AC. It has three possibilities. If it is 0, then there is no problem. If it is 0, then square root of 0 is 0, which is real number. We have no problem. If it is positive or 0, then there is no problem, because square root of positive number is a positive number. There is no is a real number actually. But if this is negative, then we will use some complex analysis. So if b square minus 4ac, which is the inside the square root, if inside the square root is negative, then we have studied in the third case above, if this thing is negative, then the square root of that thing is in the complex number but not in the real numbers. So that means we are going to land in C, in the set of complex numbers. So in other words, then this equation, this equation has no real solutions. Then the quadratic equation has no real solution but a complex solutions. Okay, so this is the case. So we consider that this is a real number. If we consider its square root is v, if b square minus 4ac square root is a complex number v, and v is now a complex number. Why it's a complex number? Because our discriminant is negative. If it is negative, we call it a complex number, so that means it belongs to C. Then the quadratic formula will become, okay, then the quadratic formula, in this quadratic formula we will write here v instead of this, because we have considered that it is a complex number, so I can call it v. Okay, then we have two solutions, a real number plus and minus a complex number over 2a. That means we are getting a complex number, because here the complex number is involved. So that means these are the two solutions, the one with plus and the other one with minus. The one solution with plus and the second solution with minus. So these are the two different solutions, but they are in the complex numbers. Now look at an example. In this example, we have to solve z square minus 6z plus 13 equals 0. Here, if I compare this quadratic equation with this quadratic equation, anything with power 2 is a, anything the coefficient of x power 1 is b, and anything with no variable is c. Since the power 2 is z power 2, the coefficient of z power 2 is 1 here, so I will consider a is 1, b is minus 6, because the coefficient of z is minus 6, and the constant is 13, so I can say c is equal to 13. Okay, now I can use the quadratic formula. Using quadratic formula, my value z will be negative b plus and minus b square minus 4ac over 2a will be equal to negative, what is b? Okay, b is negative 6. That means negative b will be plus 6. So I will write plus 6 plus and minus. B square means square of negative 6 will be 36. So I'll write 36 here. Minus 4 a times c. A is 1 and c is 13. So I will write 1 times 13 over 2 times a. A is 1. Now if I solve it, it is 36 minus 52 divided by 2, which is 6 plus minus negative 16. Now you can check the thing inside the square root is negative. So I told you that if the thing is inside the square root is negative, that means we are going to land in C. We can write this thing in this way, just like previously. If the thing inside the square root is negative, you can write it negative 1 times 16 over 2. You will get 6 plus minus negative 1 times 16. You can separate the square root of both. Here I will have 6 plus minus. This thing is iota because square root of negative 1 is iota. This thing is 4 because square root of 16 is 4 over 2. So you have 6 plus minus 4 iota over 2. Now you can distribute this 2 over here and over here. I mean this way, 6 by 2 plus minus 4 iota by 2. You will have 6 by 2 is 3 plus minus 4 by 2 is 2. You have two different complex numbers, one times ones with plus and ones with minus. So this is all. Okay, the theory is not difficult. Just you will have a quadratic equation. You have to use this quadratic formula. First of all, you have to find what is a, what is b, and what is c. Then you have to apply the quadratic formula and put the values. If inside the thing is negative, then you will do this technique, minus 1 times that number. Minus 1, square root of minus 1, you will write iota. If this is not negative number, then there is no problem. You will use your calculator to solve this quadratic equation.